Okay, so hello everyone. Let's welcome this new term with positivity and eagerness to learn more about pre-calculus. So the focus of our discussion for this week is about series and sequences. Let's start our discussion with sequences. So what is a sequence? A sequence is also called as progression. It is an ordered list of numbers. The numbers in this ordered list are what we call the elements or the terms of our sequence. So there are two types of sequences. You have finite sequences and infinite sequences. Any sequence possessing only finite number of terms is a finite sequence. Any sequence possessing infinite number of terms or which contains infinitely many terms are what we called or termed as infinite sequence. So here are important concepts we need to learn about sequences. A letter with a subscripts are often used to denote the various terms in a sequence, such as a sub 1, a sub 2, a sub 3, and so on. The sum of the first n terms of the sequence, whether it be a sub 1, a sub 2, a sub 3, and so on, may be indicated by writing as a sub 1 plus a sub 2 plus a sub 3 plus until we have a sub n. Now we have sigma notation. There is another way to indicate the sum of the sequence using sigma notation. The Greek capital letter sigma is written as this symbol. So in writing the sequences in sigma notation, we have to take note of the following parts of our notation. So we have this symbol is your sigma symbol. Then you have the formula here for the terms of your sequence. And we have this one. This is our index of summation is any letters here represented. Any possible letters. Next, first value of n. Then we have the last value of n in the upper portion of your notation. Express the following without sigma notation. So this is as an example for us to better understand the concept and the theory of sequences about sigma notation. So we have for the first item, we have a sigma notation with 3n minus 2 squared as our term, starting from 1 to 3 as the value of our n. For letter B, ix raised to the power of I minus 1. We have index represented by letter I from 1 to 4. So for our solution, we have, for letter A, we have, in order to perform the operations, it is simply to replace the variable n successively by 1, 2, and 3. So, pandumunta lang kung di nag-start or tantabunta lang kung di nag-start ang aton nga term. So, kung anong kung di ma-start ang atong substitution. So, take note of the first term, n is equal to 1. So, let's start with 1 dali. And then it ends with 3. So, ang aton last may substitute is 3. And that is successively. So, both silingon 1, 2, 3. So, sir, diyan siya namon i-substitute. So, i-substitute mo ang imong 1, 2, and 3 sa aton nga term or formula sa aton nga term, which is 3n minus 2 squared. So, substitute mo lang dara. Then, i-add mo ang result that will be your summation or imong nga answer sa imong sigma notation. So, substitute mo lang di ang value. So, performing the operations, ang makuha natin is 1 squared, 4 squared, 7 squared. So, we have 3 times 1 minus 2, that is 1. 3 times 2 minus 2, that is 4. 3 times 3 minus 3, that is 7. Amo na nga may 1 squared, 4 squared, 7 squared. And then, if we add this one, we have the answer nga 66. And that is the value of your sigma notation. Next, for letter B, we have still same on Japon nga process. Replace the variable I successively by 1, 2, and 3, and 4 since it starts with 1 here and ends with 4. Then, perform the operation and add the result. So we have 1x raised to 0 plus 2x raised to 1 plus 3x squared plus 4x cubed. And if we perform mathematical operations here, we have 1 plus 2x plus 3x squared plus 4x cubed. And this now will be our final answer. Okay, another example. Use sigma notation to rewrite the sum. So we have sine x plus sine 2x plus sine 3x plus ellipsis representing a lot of terms after sine 3x plus sine nx. So our task now is to reverse the process and find the sigma notation for the specific problem. So, except for the collection before x, sabot silingon collection before x, ang ari nga value ang sign. Each term in the sum is the same. So, the coefficient in front of x run from 1 to n. So, ang nagbago lang dari is ang imong coefficient upod ng x. So, dari may ara ka 1, may ara ka dari 2, may ara ka dari 3, then may ara ka n sa punta. So, amo lang na ang nag-change sa aton nga problem. The coefficient in front of x run from 1 to n. This tells us to use dummy variable or ang ato nga index of summation which will run from 1 to n. So take note kung ano ang index of summation naton. So bisan ano lang na din nga alphabet pwede natin gamiton or ano nga letter pwede natin gamiton. But except sang letter n. So nga hindi pwede ang letter n kay ginagamit naton ang letter n diri sa babaw as our final nga or last nga term since naka-indicate man diri sa given nga may n kita. So we have to copy sa aton nga collection diri which is sign or sang operation, then we have I diri kay amo ning substitute naton and then x. So we reverse lang the process and we find the sigma notation sa aton nga specific nga equation. And that is now our final answer. Okay, another example. We have list the first 6 terms of the sequence specified by a sub 1 is equal to 1, a sub 2 is equal to 1, and a sub n is equal to a sub n minus 1 plus a sub n minus 2, wherein n should not be greater than or equal to 3. So it is specified here. We have our recursive formula, which is a sub n is equal to a sub n minus 1 plus a sub n minus 2. So, medyo hapos lang niya kung ang ginapapangita sa aton is ang terms of the sequence. So, what we need to do is substitute values na lang kung ginapapangita sa aton ang terms. So, we have a sub 1, so given na daan, a sub 2, given na daan. So, a sub 3, so since nakabutang a sub n minus 1. Ang tanan nga n, substitute na lang natin sa ang values ng n. So, 3 ang aton nga n. So, we have a sub 3 minus 1 plus a sub 3 minus 2. So, that is equal to a sub 2 plus a sub 1. Then, substitute ang values ng a sub 2 kag a sub 1 mo. A sub 2 natin kag a sub 1 is pareho nga 1. So, 1 plus 1 is equal to 2. So, for the succeeding terms, we have a sub 4. So, if we perform operation, we have a sub 3 plus a sub 2. So, that is 2 plus 1 is equal to 3. Same also with a sub 5. So, performing mathematically, we have a sub 4 plus a sub 3. Then, substitute values of your a sub 3 and a sub 4. We have 3 plus 2 is equal to 5. For a sub 6, same process siya po na ating gamitan. We have a sub 5 plus a sub 4. So, plus. So, we have 5 plus 4 is equal to 8. So, take note nga ang a sub n is equal to a sub n minus 1 plus a sub n minus 2 is our recursion formula. So, recursion or recursive nga formula that can be used to generate terms of the sequence in terms of preceding term. So, ma-predict na nimo or mabalaan na nimo ang next in terms of the sequence gamit ang mga preceding term. So, that is the final answer natin sa problem. So, ang mo lang na-list down mo lang substitute values and then list down ang tanan nga values that will be our final answer kung ginapapangita sa imo ang terms of the sequence. Okay, another example. Find the general term of the sequence whose first 4 terms are. So, this time, given kita sang apat ka initial nga term. Then, pangitaon nato ng iyang general term. So, we have for letter A, we have 5, 6, 7, and 8. And for letter B, we have 2, negative 4, 8, and negative 16. Okay, for letter A, we have 5, 6, 7, 8. Since these terms are consecutive integers, one solution would be a sub n is equal to n, wherein n is greater than or equal to 5. So, medyo hapos na siya. Since nakabalo na kita nga, let's start with 5. So, both silingon, kay continuous man, ang ating nga number, wala man siya nag-end. So, both silingon, any number starting with 5, pasaka, so that is the value of your n. So, pwede natin magamit ang a sub n is equal to n, wherein n is greater than or equal to 5. So, but ang pinaka namin ang solution is this one. Another solution, b n is equal to n plus 4. So, sir, paano na siya, sir, nagmas namin yung solution? Kay pwede, kada rin makasubstitute values. So, atong na first term is 5. So, take note. Nga ang aton nga 5 is our first term. So, kung masubstitute kita the first term, so this is 1. So, 1 plus 4 is equal to 5. Sa second term natin, 2 plus 4 is equal to 6. Sa third term, 3 plus 4, that is 7. Then 4 plus 4 is equal to 8. So, bisan ipapangita pa sa imo kung ikapila nga term, medyo hapos siya nimo abalaan if you have this formula. For letter B, we have 2, negative 4, 8, and negative 16. So, medyo nabalaan ta na nga daw multiply lang siya. But, niara kita alternating nga negative sign. Each of these terms can be written as the product of the formula of 2 and the power of negative 1. So, take note kada perme nga if may ara ka alternating nga sign. So, take note nga, it is multiplied by the power of negative 1. So, take note lang na kada perme. Kung may alternating ka nga sign, positive, negative, so that is power of negative 1. So, tanaw mo naton nga ang aton nga term is 2, negative 4, 8, 16. So, they are power of 2. So, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 3, and 2 raised to the power of 4. But, ang kinalain ng nila sa sign. So, hambal ko, gamiton natin ang alternating nga formula, which is negative 1 raised to the power of. So, we have negative 1 raised to the power of 0. So, this is 1 man Japon kay any number raised to the power of 0 that is equal to 1. So, that is 2 raised to 1 is positive 2. Next, negative 1 raised to the power of 1 is negative 1 times 4 is negative 4. Next, negative 1 squared. So that is positive 1. So that is times 2 cubed is equal to 8. For negative 16, negative 1 cubed. Negative 1 cubed is negative 1 multiplied by 2 raised to the power of 4, which is 16. You have negative 16. Then, kung tanawon nato, na-inspect nato na ato na himo nga solution. Our solution is a sub n multiplied by negative 1 times n minus 1 over 2 raised to the power of n. That is now our final answer. Okay, this time, we will proceed with series. So, dali natin mabalaan kung anong kinalain sa sequences and series. Okay, series is the sum of the terms of the sequence. So, the sum of the terms of the sequence, medyo nahimo ta nakagina, ba't wala ta kabalo nga? Series, ito siya gali ang tawag. Series are often represented in compact form called summation notation using symbol nga sigma. So, naka-perform as operation related to this kagina, pero wala kita kabalo nga series gali ang tawag siya. So, example, given the sequence 1 over 2, 1 over 4, 1 over 8, up until 1 over 2 raised to the power of n. So, the corresponding series is, tangan mo lang sila addition symbols tungaan nila. That will be your series na. 1 half plus 1 fourth plus 1 eighth plus blah 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 up to 1 over 2 raised to the power of n. And more compactly, para ma-illustrate mo siya into a series form, we are going to use the sigma notation. So, summation notation. So, 1 over 2 raised to the power of I is equals to I, or starting from I is equal to 1 up until the value of n. So, up to sa bisan ano nga value sang n. So, that is already your final answer. Okay, another one. Write without summation notation. So, given naman dariya ang sigma nga formula. So, ang naka-summation notation na siya or naka-compact form na siya. So, we have I minus 1 over I, wherein I starts from 1 up to 5. So, ang solution dari is substitute values lang liwat sang value ka I. So, starting from 1, we have 1 minus 1 over 1, 2 minus 1 over 2, 3 minus 1 over 3, 4 minus 1 over 4, 5 minus 1 over 5. Then, add na lang dayon para sa aton nga summation notation. So, performing operation, we have 0, 1 half, 2/3, 3/4, 4/5. Then, add natin sila. That will be our final answer. Okay, another example. Write using summation notation. So, ang ginhatag niya sa aton is 1 minus 1 half plus 1/3 minus 1/4 plus 1/5. So, take note, for this problem, ara kita liwat alternating signs. So, take note, balikan natin anong kinahimo kung may alternating signs kita. So, we have to multiply it by the power of negative 1. So, take note lang. And take note nga naghambal siya aton summing index should start at k is equal to 1 sa letter A. For letter B, should start at k is equal to 0. Okay, for our solution, we know nga, or nakita natin nga may alternating negative sign or alternating sign na ato nga sequence or ato nga series. So, kabalo kita nga it should be represented by negative 1 or the power of negative 1. But, somehow take note nga kung ano nga sign nag-start ang ato nga series. So, if it start with positive, so, buot silingon, ang aton nga unang term should be negative 1 raised to the 0. So, tandaan lang na. If positive, negative 1 raised to 0, and if negative, negative 1 raised to 1. So, take note kung kada permi. Since din-mention niya nga dapat for the first term, start dapat ang aton nga index of summation by 1. So, we have negative 1 raised to 0 dapat. So, dapat k minus 1 kita sa atong exponent para mag-0 siya. So, that is negative 1 raised to power of k minus 1. It provides the alternation of the sign. And take note nga ang aton nga other term or other parts ng aton nga kada term is 1 over k lang siya. So, 1 over k. So, this one is negative 1 k raised to k minus 1 multiplied by 1 over k. Simplifying sa aton nga equation, ipasaka ta lang negative 1 raised to k minus 1 multiplied by 1. So we have negative 1 raised to k minus 1 all over k from k is equal to 1 up to sa 6. So that is our final answer. For letter B naman, same man Japon, it starts with positive. So we know that we are going to use the power of negative 1. However, ginhambal sa aton nga problem nga dapat k should start with 0. So positive siya, so kabalo kita nga dapat raised to the power of 0 siya. So hindi na natin kinanglan mag-minus pa with sa aton nga exponent. So that is 0 na siya daan, so that is k na lang sa aton exponent. Negative 1 raised to k provides the alternation of the sign. Then, sa aton nga sa dalong, since nakita naton, hindi na siya pwede mag-k lang. Kay negative 1. So, hindi pwede nga 1 over 0 ang aton first term. So, that is 1 over 0 plus 1. So, that is 1 over k plus 1. Provides the other part of each term. So, simplifying or sa aton nga collapse na form, so we have negative 1 raised to the power of k over k plus 1, wherein k is from 0 as nasa 5. That is our final answer. So that is our topic for the introduction to sequences and series. So, however, may ara pa ta isa pagid ka topic for this week, which is about arithmetic nga series or sequence. So, this is for this topic lang. So, stay safe everyone. Thank you and God bless.